Standard Mathematics, Chapter 7, Variation, Module 3. In this module, we'll study about problem sums related to time, work, and speed. Examples related to the number of workers and the time taken to finish the workers. They are all examples of inverse variation. Similarly, there are some examples related to the time taken to cover a distance by a vehicle and its uniform speed. This is also an example of inverse variation. Such examples of variations are examples related to time, work, and speed, and these all are inverse variation type examples. Now we will see how to solve such examples of a variation. One thing to note that if the question or if the problem sum is about time, work, or speed, then that problem sum will be about inverse variation. Let us see an example. 15 women finished the work of harvesting a groundnut crop in 8 days. Find the number of women in the same job is to be completed in 6 days. Let us start with the solution. The number of days required to finish a job is inversely proportional to the number of women employed. Let the number of days be denoted by D and the number of women be denoted by N. As they are in inverse proportion, D is inversely proportional to 1 upon N, and the equation form will be D into N is equal to K, where K is the constant of variation. If N is equal to 15, then D is equal to 18. That is, it is given in the question, 15 women finished the work in 8 days. Using this information, we will find out the value of K. So K is equal to D into N, which is 15 multiplied by 8, which is nothing but 120. So the value of K, that is the constant of variation, is 120. Now let us find out N when D is 8. That means we have to find the number of women when D is 6. That is when the job is completed in 6 days, how much women will be required. So D into N equal to K. Substitute the value of D as 6 here. So this will be 6 into N, which is equal to 120. Divide both the sides by 6, you will get N equal to 120 divided by 6, which is 20. So 20 women should be employed to finish the work in 6 days. Problem number 2. A vehicle running at a speed of 48 km per hour takes 6 hours to complete the journey. How much time will be taken to complete the journey if its speed is 72 km per hour? Let us start out with the solution. Let us assume the speed of a vehicle to be s and the time taken to travel be t. Clearly, this is an inverse variation in speed and time. So s is inversely proportional to 1 upon t. Therefore, s into t equal to k, where k is a constant of variation and this is the equation of variation. So k is equal to s into t, where s is 48 and t is 6. So 48 into 6 is 288. Therefore, the value of k, the constant of variation, is 288. Now let us find t when s is 72. So in place of s, substitute 72. So we get 72 multiplied by t is equal to 288. Here divide both the sides by 72 and you get t is equal to 288 upon 72, which is 4. So the value of t is 4. Therefore, the time taken to travel the same distance at the speed of 72 km per hour is 4 hours. Practice set 7.3, first sum. Which of the following statements are of inverse variation? So the first one is number of workers on a job and the time taken by them to complete the job. So the number of workers on a job and the time taken by them to complete the job are in inverse variation, as increase in the number of workers on a job decreases the time taken by the workers to complete the job. Second one, if you see number of pipes of the same size to fill a tank and the time taken by them to fill the tank. So the number of pipes of the same size to fill a tank and the time taken by them to fill the tank are an inverse variation, as increase in the number of pipes of the same size to fill a tank will decrease the time taken by them to fill the tank. Hence, it is an example of inverse variation. Third one, petrol filled in the tank of a vehicle and its cost. The petrol filled in the tank of a vehicle and its cost are in direct proportion, as increase in the amount of petrol filled in the tank of a vehicle will also increase the cost for the petrol. Hence, this is an example of direct proportion. The fourth one, area of a circle and its radius. So the area of a circle and its radius are in direct proportion. As you increase the radius of the circle, the area of the circle will also increase. Hence, this is also an example of direct proportion. Question number 2, a problem sum. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Now, clearly, if you read the question carefully, it is a problem sum based on time and workers. So clearly, this is an example of inverse variation. Let us start with the solution. The number of hours required to build a wall is inversely proportional to the number of workers employed. Let the number of hours be denoted by H and the number of workers be W. So here H varies as W. That is, the symbolic form of the variation will be H inversely proportional to 1 upon W. The equation will be H is equal to K upon W, where K is the constant of variation. Therefore, H into W is equal to K. This will be the equation of variation. Now, it is said 48 workers, 15 workers can build the wall in 48 hours. So when H is 48, W is 15. Substitute the values of H and W in your equation of variation and find the value of K. So K is equal to 48 into 15, which is 270. So the value of K, that is the value of your constant of variation, is 720. Substitute the value of K in your equation of variation. So your equation of variation is H into W is equal to 720. HW equal to 720. Now they've asked in 30 hours, how many workers will be required to build the wall. So when H is 30, we have to find the value of W. So substitute the value in your equation of variation. You get 30W is equal to 720. Divide both the sides by 30 and you get W is equal to 720 divided by 30, which is 24. So the number of workers required to do the same work in 30 hours is 24. Question number 3. 120 bag of half-liter milk can be filled by a machine within 3 minutes. Find the time to fill such 1800 bags. The time required to fill the bag of milk varies directly as the time required to fill the bag. Let the number of minutes be x and the number of bags be y. Here x varies directly as y, that is x is directly proportional to y. So the equation will be x is equal to ky, where k is the constant of variation. Now when x is 3, y is 120. Substitute the values of x and y in your equation of variation and find out the value of k. So we get 3 is equal to k into 120. You divide both the sides by 120, you'll get k is equal to 3 upon 120, which is 1 upon 40. So the equation of variation will be x is equal to 140y. X is equal to 1 upon 40y. Now, when y is 1800, we need to find the value of k, of x. Substitute the value. So you have x is equal to 1 upon 40 into 1800, which will give you 45. Thus, the time required to fill 1800 bags with milk is 45 minutes. If f is inversely proportional to 1 upon d square, when d is 5 and f is 15, we have to find when d is 10, value of f, and when f is 50, the value of d. So f is inversely proportional to 1 upon d square. Therefore, the equality sign equation will be f into d square equal to k. This is the equation of variation and k is the constant of variation. Substituting the value of d and f, so f is 15, d is 5, so 18 into 5 square is equal to k. Therefore, k is equal to 18 into 25, which is 450. Therefore, the constant of variation is 450. Now, if d is 10, we have to find out the value of f. Substitute the value of d in your equation of variation. F into d square is equal to 450. F into 10 square is equal to 450. So f into 100 is equal to 450. Divide both the sides by 100. So you get f is equal to 4.5. Second, if f is 50, we have to find the value of d. So substitute the value in your equation of variation. F into d square is equal to 450. So 50 into d square is equal to 450. Dividing both the sides by 50, we get d square is equal to 9. Now by taking square root on both the sides, you get d is equal to plus 3 or d is equal to minus of 3. A problem sum. A car with speed 60 kilometers per hour takes 8 hours to travel some distance. What should be the increase in the speed if the same distance is to be covered in 7.5 hours? Let us start with the solution. The speed of the car is inversely proportional to the time taken by the car to travel the distance. Let the speed of the car be s and the time taken by the car to travel the distance be t. Here, s varies inversely as t. That is, s is inversely proportional to 1 upon t. This in the form of equation will be s is equal to k upon t, where k is the constant of variation. So s into t is equal to k is your equation of variation. Now in the question it is given when the speed is 60 kilometers per hour, the car takes 8 hours to travel. So when s is 60, t is equal to 8. Now we substitute the values of s and t in your equation of variation to find out the value of k. So we have k is equal to 60 into 8, which is 480. So the value of the constant of variation k is 480. And the equation of variation will be St is equal to 480. Now, when t is 7.5 hours, that means when in 7.5 hours, how much distance will it cover? So 7.5 hours means 15 upon 2. So when t is 15 upon 2, we have to find out the value of s. So s into 15 upon 2 is equal to 480. We are substituting this in our equation of variation. Multiplying both sides by 2 upon 15, you get s is equal to 480 into 2 upon 15. We need to find the increase in the speed. So the increase in the speed will be 64 minus 60, which is 4 kilometers per hour. Here if you see, the value of s will be 64. So when time is 7.5 hours, the speed will be 64 kilometers per hour. Hence the increase in speed will be 64 minus 60, which is 4 kilometers per hour. Thus, the increase in speed of the car is 4 kilometers per hour.